All right, now we're going to talk about compound inequalities. Now, inequality, we know, means it has an inequality symbol, greater than, less than, greater than or equal to, less than or equal to. Compound means we're doing two at once, okay? So when we're doing compound inequalities, we're really noticing, right, that there's two inequalities kind of combined into one. The first inequality in this problem is -2 is less than or equal to -3x plus 5. Now we know how to solve that inequality, okay? And if we were to solve that, we would do something like subtract 5 from both sides. -2 minus 5 is -7, less than or equal to -3x, 5 and -5 cancel. And then we would divide by -3. Now I'm dividing by a negative, so the warning bells in my head should be going off. Anytime we multiply or divide by a negative, we need to switch the direction of our inequality. -7 divided by -3, negative becomes a positive. So I have 7/3 is bigger than or equal to -3 cancels, x. So here's half of our solution. 7/3 is bigger than or equal to x. Another way of saying that is I can rewrite this. We're more used to seeing x on the left, so I could rewrite this as x is less than or equal to 7/3. Notice these say the same thing. 7/3 is bigger than x is the same thing as saying x is smaller than 7/3. Okay. Now let's look at the other inequality that's kind of hidden inside of here, and that's this guy. So the second inequality in our compound inequality is -3x plus 5 is less than or equal to 4. Now we can solve this. I would solve this by subtracting 5 from both sides. -3x, 5 and -5 cancels is less than or equal to 4 minus 5 is -1. Then I would divide both sides by -3. And again, warning bell should be going off because we're dividing by a negative, which means the direction of our inequality needs to switch. -3 divided by -3 cancels, leaving me with x is bigger than or equal to -1 divided by -3 is positive 1/3. So here's the second part of our answer. Okay, I'm going to talk about how we combine those two answers together in a minute. But before we do that, I'm going to look at the steps that we did. So first, in both of these, we subtracted 5. And then we divided by -3. Okay, so oftentimes when we're solving compound inequalities, as opposed to splitting these out into two different inequalities, we solve them all at once. So what do I mean by that? -2 less than or equal to -3x plus 5. Well, I could have kind of short-circuited these two things by subtracting 5 and just doing it in all three places, right? So I'm doing it here for this side, doing it here for this side. But look at what happens when I do that. -2 minus 5 is -7, less than or equal to, my 5 and -5 cancels, -3x less than or equal to 4 minus -5, -1. Okay? And then I'm going to divide everything by -3. Now I'm dividing by a negative, which means I'm going to have to flip the direction of all of my inequalities here. So less than or equal becomes greater than or equal, less than or equal becomes greater than or equal. -7 over -3 becomes positive 7/3 is greater than or equal to x, which is greater than or equal to 1/3. Okay? Notice that I did the exact same steps from the blue and the pinkish purple. I just did it all at once. As opposed to solving two inequalities, I solved this compound inequality doing the same thing. Okay? Now let's think about what this means for our answer. Okay? There's two ways to think about our answer. Right? First, I'm going to look at what we have here. This says x is sandwiched between 1/3 and 7/3. All right. Well, I'm going to draw a number line and put in some thirds. Okay, so here's 0, here's 1, here's 2. So then here would be 1/3, 2/3, 1/3, 2/3, 3/3, 4/3, 5/3, 6/3, 7/3. Okay, so we're saying here that x is between 1/3 and 7/3. Now we're going to include 1/3 because we've got this equal to part. So here's our answer. X is between 1/3 and 7/3. How would we write that as an interval? Well, this interval starts at 1/3 and goes to 7/3. we're including 1/3, and we're including 7/3. Okay, so here's our answer. Now another way we could have seen that answer is by using our two separate inequalities. So if we use our two separate inequalities, let's draw another number line. I'll draw it up here. Okay, then again, here's 0, here's 1, here's 2, there's 1/3, 2/3, 3/3, 4/3, 5/3, 6/3, 7/3. Okay, and I'm going to draw in both of these inequalities. This says x is less than or equal to 7/3. So here's 7/3. I'm going to start at 7/3. Solid circle because we're less than or equal to, and we're less than. So we're moving in that direction. So that blue line represents this blue inequality. And then this purpley pink marker we're going to use to represent x is bigger than or equal to 1/3. Well, here's 1/3. We're bigger than or equal to, so solid circle, and we're bigger than, moving in this direction. Okay. Now the answer to the compound inequality has to satisfy both the blue line and the pink line, purple line, whatever color you want to call that. In other words, it's going to go from 1/3 to 7/3. All of this is covered by both of those lines. As an interval, that would be 1/3 to 7/3, including 1/3 and including 7/3. The same thing we got down here. Okay? So compound inequality is just solving both inequalities at the same time. Let's look at another example. All right, here's another example. Now let's try and solve this one all at once. Okay, so I'm going to try and solve this by solving the two inequalities. This guy, -2 is less than or equal to x minus 4 divided by 6. And this guy, x minus 4 divided by 6 is less than or equal to 2 at the same time. So the first thing I would want to do is get rid of that 6 in the bottom. So that means multiplying everywhere by 6. Okay. Now I'm multiplying by a positive, so I don't need to worry about flipping the sign. 6 times -2 is -12, is less than. 6 here and 6 here cancel, so I'm just left with x minus 4 is less than or equal to 2 times 6 is 12. Now I'm going to add 4 everywhere. -12 plus 4 is -8, which is less than. -4 and +4 cancel. So x less than or equal to 12 plus 4 is 16. So here's my answer. X is bigger than -8, but smaller than or equal to 16. In other words, x is sandwiched between -8 and 16. So I'm going to draw a number line. Here's 0. Somewhere over here is -8. Somewhere over here is 16. Okay. And I know that x is bigger than -8. So bigger than -8. I'm leaving an open circle. Why? Because this is strictly bigger. But smaller than or equal to 16. Okay. So here's my interval. As an interval notation, this would be -8 to 16. I always work left to right. I'm not going to include -8, open circle, strictly bigger than. I am going to include 16. Closed in circle, smaller than or equal to. So there's our solution. Okay, so real quickly, I do just want to do a quick side note about compound inequalities. We're specifically looking at compound inequalities of the and flavor. So that means I'm solving an inequality something like 3 is less than or equal to 4x plus 7, and 4x plus 7 is less than 9. When I have this and, I can put these together to be that kind of big, almost run-on inequality. 3 is less than or equal to 4x plus 7, which is less than 9. Okay, this is using the conjoiner and here. There is a second flavor. It's this flavor that we're not really getting into yet in this class, and that's the or flavor. Okay, so I can have an or inequality, something like x is less than 3, or x is bigger than or equal to 5. Now notice when I join these together, it looks a little bit different. If I wanted to join these together, I'd put x in the middle, and I would have x is bigger than or equal to 5, and x is less than or equal to 3. Okay, so these are gonna be something slightly different when we do this or, because they're gonna build out to look a little bit different. Okay, And so again, we're really focusing on the and version here, but there is also this or version that looks slightly different, okay? So we're going to get into the or a little bit later when we do absolute value inequalities. But in particular, if I look at this, right, x is less than 3. If I graph that on a number line, so I have these two things graphed on a number line. So here's 0, 1, 2, 3, 4, 5. Okay, wow, there's 1, 1, 2, 3, 4, 5. Okay, if I look at these two or statements, x is less than 3. Well, that looks like this. X is smaller than 3. And if I look at x is bigger than or equal to 5, well, that looks like this. Notice that these never overlap. However, or in terms of math means you can do this or that. You don't have to be both at the same time, okay? So that means I could have everything over here, negative infinity to 3, or 5 to infinity. So I could union those two solutions together. Again, this week's homework is going to focus on the and compound inequality, but I just want you to be aware that there's the second flavor out there that we will see later.